electric and hybrid vehicle engineering inside hybrid and electric vehicles. In this lesson, we'll study about hybrid electric vehicle and cover all the aspects regarding HEV, and the topics we will be covering are introduction, where we'll discuss what is HEV and about regenerative braking. Then coming towards history, where we'll see first hybrid vehicle. Then we'll have a distinction between hybrid vehicles and electric vehicle. And at last, types of hybrid electric vehicle. Now coming over to introductory part of HEV. What is HEV? As you can see from the GIF that is presented about hybrid vehicle, you can estimate that a hybrid combines at least one electric motor with a gasoline engine to move the car, and its system recaptures this energy with the help of regenerative braking. Sometimes the electric motor does all the work, but sometimes it's a gas engine, and sometimes they work together. This result is less gasoline burned and therefore better fuel economy. Here, electricity comes from a high voltage battery pack that is separated from the car's conventional 12-volt battery, and which is further replenished by the help of regenerative braking while capturing energy from deacceleration, which is typically lost due to heat energy by the brakes in conventional car. This happens through the regenerative braking system. For all of you who don't know about regenerative braking system, don't worry, we will be covering this in our next slide. Coming back to HEV, hybrid also use the gas engine to charge and maintain the battery. Therefore, car companies use different hybrid designs to accomplish different missions, ranging from maximum fuel savings to keeping the vehicle's cost as low as possible. Now coming over to regenerative braking system, as we all know that moving vehicles have a lot of kinetic energy, and when brakes are applied to slow vehicle, all of that kinetic energy has to go somewhere. Therefore, we make use of that kinetic energy in the case of regenerative braking. As you can see in this video, when brakes are applied to an accelerating vehicle, all of that kinetic energy is converted with the help of electric vehicle's motor, which acts like a generator at that time to convert much of that energy back into stored energy in the vehicle's battery. Therefore, the next time the car accelerates, it uses much of the energy previously stored from regenerative concept instead of tapping in further to its own energy reserve, that is from the battery. Therefore, we can also evaluate regenerative braking by looking into two different parameters: efficiency and effectiveness. They both sound similar, but in reality they two are quite different. As you all know, no machine can be 100% efficient, and as any transfer of energy will inevitably have some losses such as heat, light, noise, etc. Therefore, coming to efficiency of the regenerative braking process, it varies from many vehicles, motor, batteries and controllers, but is often somewhere in the neighborhood of around 60 to 70%. Regenerative also loses around 10 to 20% of that energy which is being captured, and then the car loses about 10 to 20% or so when converting that energy back into acceleration. Therefore, Adding to this, driving conditions also have a large impact over the regenerative braking. As you say, you will see much better effectiveness of regenerative braking in stop and go city traffic than in highway commuting. As if you are repeatedly braking, you will recapture a lot more energy than if you simply drive for hours without touching the brake pedal. Therefore, you can say that terrain also play a large role here, as uphill driving doesn't give you much chance for braking, but downhill driving will regenerate a much larger amount of energy due to the long braking periods. And on long downhills, regenerative braking can be used nearly constantly to regulate speed while continuously charging the battery, which is quite an efficient option here. Now let us have a look on history of hybrid car. We will be studying this in 3 phases, covering the first phase, that is the beginning phase. The first hybrid car was built in the year 1899 by engineer Ferdinand Porsche, which was called the system as Lohner Porsche Mixte, which used a gasoline engine to supply power to an electric motor that drove the car's front wheel. As you can say, it is a front wheel drive car. Then the demand for hybrids began to low. However, when Henry Ford started the first automobile assembly line in 1904, Ford's ability to produce that gasoline-powered cars and offer them at lower price dramatically shrunk the hybrid vehicle market. Therefore, while hybrids were produced well into the 1910s using that technology that was done by Ferdinand Porsche, most sold poorly because they had higher prices and less power than their gasoline-powered counterparts. Therefore, hybrids soon become a thing to the past and the production starts to decline. Coming over to next phase, that is the renewed interest. In the era of 1960s, the United States Congress introduced some schemes that encourage greater use of electric vehicle. It was due to an attempt to reduce air pollution. While the government tried to garner support for the hybrids, renewed public interest didn't gain momentum until the oil crisis that was caused due to the higher growing price of gasoline. And then over the next 25 years, auto manufacturers spent billions of dollars on research and development of hybrid technologies. But in spite of this, very few vehicles were produced that will both reduce the world's dependence on oil and compete with gasoline vehicles on price and performance. But then coming to next phase, the hybrid electric vehicle had a rebirth. In the year 1999, the Honda Insight became the first mass production hybrid electric vehicle released in the US. The two-door, two-seat Insight may have been the first, but it was the Toyota Prius sedan released in the United States in 2000 that gave birth to hybrid technology and provide the foothold it was looking for. Then in the following years, United States started introducing many models, but the Prius has become synonymous with the term hybrid. It was considered one of the most popular hybrid electric vehicle which was ever produced, and auto manufacturers around the world have used its technology as a basis for countless other vehicles manufacturing. And adding to this, as hybrid technology continued to improve, it started developing an even stronger foothold in the world's auto market. Now coming over to next topic, that is hybrid electric vehicle component. Here almost all the components are same as that of in electric vehicle. Here first, electric traction motor. It is responsible for generating power or providing enough traction for our vehicle to move further. Then power electronics controller, which is used for governing all the electronics part that is present in our vehicle. DC converter, which is responsible for providing necessary DC current to all the components, electrical components that are present in our vehicle. Thermal system, which is required for providing an optimum temperature for all the components in our vehicle to function properly. Fuel tank, which is necessary for storing of oil or diesel depending upon the engine type. Then fuel filter, electric generator, which can be used for transferring of power from IC to battery for the purpose of recharging. Then transmission, IC engine, and exhaust system. Exhaust system is a vital part because it is useful in converting the NOx gases and thus reducing the pollution. Now coming over to types of hybrid, they can be categorized majorly into three types: parallel hybrid, series hybrid, and plug-in hybrid. We will be discussing about the types of hybrid in our further lecture. That is all for today. Thanks for watching.